Hello everyone, welcome back to Lemon Code 21. In this session, we will learn into the basics of Docker. Before learning Docker, you should be able to understanding operating systems, understanding how to install applications, understanding how to use commands in the terminal/command line, understanding virtual machines. But if you can't, it's okay. You can learn while studying this material. This is the material that we will discuss in learning the basics of Docker. Container Docker is a lightweight and efficient virtualization technology that allows applications to be packaged and run in isolated environments. Unlike virtual machines, VMs, containers focus on the application layer. Containers run on top of a container manager, which operates within the host operating system. The key difference from VMs is that containers can package applications and their dependencies without merging the operating system. Containers utilize the host operating system where their container manager runs, resulting in resource efficiency and faster performance as they don't require a separate operating system. Container sizes are typically measured in megabytes, MB, whereas VMs can reach gigabytes, GB, due to the included operating system. Docker is one of the most popular implementations of container managers today. Docker is a relatively new technology, as it was introduced around 2013. Docker is a free and open source application, allowing us to use it freely. Docker utilizes a client-server architecture. The Docker client communicates with the Docker daemon server. When we install Docker, it typically includes both the Docker client and Docker daemon. The Docker client and Docker daemon can run on the same system. The communication between Docker client and Docker daemon is done using REST API. To install Docker, you can visit the official Docker website at docker.com. There, you will find Docker installers available for various operating systems. If you're using Windows, you can choose the Windows installation option. You can also find specific installation guides for Windows under the Guides section or Desktop Guides on the website. If you are using Windows 11, you will need to install WSL2, Windows Subsystem for Linux, as a prerequisite. Once you have completed the Docker installation, you will see the Docker desktop application open. The interface of this application displays information about Docker, such as container images and volumes. Container images are templates for creating containers, while volumes are storage locations that can be used by containers. With Docker, you can create and run containers to isolate applications and their environments. Docker Registry is a place where we store Docker images. By using Docker Registry, we can store the images we create and can be used in Docker daemon anywhere as long as it can connect to the Docker Registry. In the Docker ecosystem, there are many Docker registries that provide storage and distribution services for container images. Some popular examples of Docker registries include Docker Hub, DigitalOcean Container Registry, Google Cloud Container Registry, and many more. A Docker image is similar to an application installer, as it contains the application and its dependencies. Before we can run an application in Docker, we need to ensure that we have the Docker image of that application. Let's start by opening Visual Studio Code and accessing the terminal. We will use the command docker image ls to view the Docker images that are present on our computer. And these are the Docker images that are present on my computer. There are so many of them. Now, let's attempt to retrieve the Redis image from Docker Hub. To view the versions of a Docker image for a specific application, you can visit Docker Hub and search for the desired tag. To retrieve the image, you can simply type Docker image pull image name, tag name. If it doesn't exist already, Docker will download the Redis Docker image to your PC. Now, let's create an MD file as a note. I wrote down a few notes so I don't forget, but we can already download the Docker image. Next, we will delete the Docker image. To remove the Docker image, you can use the command docker imagerum image name tag name. If Docker image is like an application installer, then Docker container is similar to the application that is installed. One Docker image can be used to create multiple Docker containers as long as the container names are different. Once a Docker container is created, the Docker image used to create it cannot be deleted. This is because Docker containers do not actually copy the contents of the Docker image, but rather use its contents. When we create a container, by default, the container will not be running. It is similar to installing an application, where the application will not run unless we explicitly start it. The same applies to containers. Therefore, after creating a container, we need to run it if we want the container to be running and functional. To view all containers, whether they are currently running or not, in the Docker daemon, you can use the following command, docker container lsa. If you only want to see the running containers, you can use the following command, docker container ls. To create a container, you can use the following command, docker container create name container name, image name, tag. To start a container that you have created, you can use the following command, docker container start containerid /container name. To stop a container, you can use the following command, docker container stop containerid /container name. To remove a stopped container, you can use the following command, docker container container rim containerid /container name. Okay, let's create a Markdown MD file as our note to avoid repeating the writing in the document. In this session, we will discuss Docker containers using the command docker container lsa. Currently, I have several active or created containers. If we look at Docker Desktop, there are many containers in my computer. Perhaps I will delete some of the containers first, so that later you can see the effects of Docker container operations. Next, we will learn how to create a container using the command docker container create name container name image name, tag name. Now, let me delete all the containers on my computer so we can see the results after creating a Docker container. Alright, you can see that it's empty now since I have deleted all the containers on my computer. Now let's create a new container. We will create a Docker container named Redis1. Then, let's type docker container ls to see the list of containers. Okay, now the container is there. It's Redis1. If we look at Docker Desktop, we can see that the Redis1 container has been created. Alright, now it's time to run the container using the docker container start container name command. We can see that the container is now running, which means that port 6379 is connected. If we look at Docker Desktop, we can see that the Redis1 container is up and running with a green indicator on the icon. Moving on, if you want to stop a container, You simply need to type Docker container stop container name or container it. Let's try typing Docker container stop Redis own. If we check, the container is stopped. If you want to delete a container, you can use the command docker container or container name. It's advisable to stop the container before deleting it. If we check on Docker desktop, you will notice that the container has been deleted. Okay, that concludes our discussion about containers. Thank you. Sometimes, when there is an issue with an application running inside a container, we often want to view the detailed logs of the application. This is done to analyze the specific events and activities happening within the application, which can help troubleshoot and identify any problems. To view the logs of a containerized application, you can use the following command: Docker container logs containerid/container name. Next, let's take a look at container logs. You can simply type Docker container logs container name or containerid. First, let's check for any active containers. It appears that there are no running containers at the moment. So let's create a Redis container and name it Redis1. Oh, since it's not available in the image, we need to pull the Redis image first. Okay, let's check the container list and view the logs of the Redis1 container. Oh, there was a typo in the command. It should be lowercase s. Alright, there's still no output because we haven't started the Docker container yet. It's important to run the container first before checking its logs. Let's check the container list again, and now the Redis1 container is up and running. This is the result. You can view the logs of the running container using Docker container logs. When creating a container, the application inside the container can typically only be accessed from within the container itself. Therefore, there are times when we need to access the container directly. To enter a running container, you can use the Continer Exec feature, which allows you to execute commands or run programs within the container. To enter a container, use the following command: Docker Continer Exec containerid/container name bash. The it flag is used to allocate a sudo ttt y and enable interactive mode, while bash is the command to start a bash shell within the container. Next, we will learn about the Docker Continer Exec command. It's quite simple. You just need to type Docker Container Exec bash containerid or container name bash. This command is used to enter a Docker container. Let's try it out with the command Docker Container Exec. It Redis1 bash. Now we are inside the Redis1 container. It means we can access the folders inside the Redis1 container. When running a container, it is isolated within Docker. This means that the host system, such as our laptop, cannot directly access the applications running inside the container. One way to access the application is by using Continer Exec to enter the container. Typically, an application runs on a specific port. For example, when running a Redis application, it runs on port 6379. To determine which port is used by a container, you can view the list of all containers. Docker has the ability to perform port forwarding, which allows you to forward a port from the host system to the Docker container. This method is useful when you want to expose a port from the container to the outside world through the host system. To perform port forwarding, you can use the P flag when running the container with the docker run command. The syntax for port forwarding is as follows: docker run p host port container port image. Instead of using publish, you can use p for the same purpose. Okay, let's get started with container ports. The process of using container ports is quite simple. You just need to type the command docker run p host port container port image name. Now, let's try port forwarding within Ginks. First, we'll pull the Ginks image. After that, we'll create a container named nginx1 with port 8080, as port 80 is commonly used for unginx. Let's run the command. Don't forget to start the container. Let's check it using the docker command. We can see that the nginx1 container has been created, but it is currently in a stop state. We need to start it. After starting the container, nginx will be running on port 8080 on our local machine. If we check it, we can see that nginx is up and running. However, if we stop it, port 8080 will be closed again. That's a brief explanation of port forwarding in Docker. When developing an application, using environment variables is one technique to make the application's configuration dynamically changeable. By utilizing environment variables, we can modify the application's configuration without having to modify the application code itself. Docker containers provide parameters that allow us to pass environment variables to the applications running inside the container. To send environment variables to a containerized application, you can use the E or NV flag when running the container with the docker run command. The syntax is as follows: docker run varname equals value image. I will take a note first in my note-taking application so that I don't forget. Now let's try to create an environment in Docker using mongodb. We will create a container using mongodb and add environment variables for the username and password. We can create a Docker container with Note that we specify the environment variable's username and password according to the ones provided by the mongodb image. To find out the available environment variables, you can visit Docker Hub and search for the mongodb image, which will provide information about the available environment variables. If we open Docker Desktop, we can see that the Mongo1 container has been created. To interact with mongodb, you can use mongodb Compass. Visit their official website to download and install the application. Once downloaded and installed, you can connect to mongodb using mongodb Compass. Let's give it a try, and it works. Now, let's try to run it. You can enter the mongodb URL with the added username and password. It's very easy to use environment variables in Docker. When running multiple containers on the host system, the usage of resources such as CPU and memory is typically attributed to Docker itself. However, there might be a need to view the detailed resource usage of each individual container. Thankfully, Docker provides a feature to monitor the resource usage of running containers. To view the resource usage of each container, you can use the following command, Docker Continer Stats. Alright, let's create a new file to display the container status. It's quite easy to view the container status. Simply run the command Docker Continer Stats. Let's give it a try. Before checking the status, let's see if the container is running or not. If it's not running, let's start it first. Once the container is running, we can check its status. Here, you can see the memory usage and limit parameters, as well as CPU usage. When creating a container by default, it will use all the CPU and memory resources allocated to Docker Macan Windows, and it will use all the available CPU and memory resources on the host system, Linux, if there are any issues, such as a container consuming too much CPU. And memory, it can impact the performance of other containers or even the host system. Therefore, it is advisable to set resource limits for containers during their creation. When creating a container, you can use the following flags to set resource limits. Docker container n container name p port, port q port, port pews equals 2 memory equals 2g imaginame, pspace equals value, or cpu shares equals value. Specify the maximum number of CPUs or the relative CPU shares that a container can use. Memory equals value. Set the maximum amount of memory that a container can consume. Let's make a note first. If you want to add resource limits for CPU and memory to the container you create, you can simply add CPU and memory options with the desired values. We will use Nginx as an example, with a memory limit of 100 MB and 0.5 core CPU. Once we create the container, we can run it and check its status. By setting resource limits, you can control the CPU and memory usage of the container, ensuring that it doesn't consume excessive resources from the host system or affect the performance of other containers running on the same system. This helps maintain stability and overall performance of your Docker environment. Now, let's run the container with the specified resource limits and observe its status. When checking the container's status, you will see that the resource usage is constrained according to the set limits. For instance, the memory usage will not exceed 100 MB and the CPU usage will not exceed 0.5 cores. By implementing resource limits, you can optimize the resource usage and ensure that containers operate within the desired boundaries, aligning with the requirements of the applications running inside them. Bind mounts allow us to mount, share files or folders from the host system to a container within Docker. This feature is extremely useful when, for example, we want to provide configuration files from outside the container or save data generated by an application inside the container to a folder on the host system. The mount parameter has the following structure: mount type equals bind, source equals source path, target equals target path. Type equals bind specifies the type of mount, which is a bind mount in this case. Source equals source path specifies the path of the file or folder on the host system that we want to mount. Target equals target path specifies the path inside the container where we want to mount the file or folder. To mount, we can use the following command: docker run mount type equals bind, source equals /host folder, target equals /container folder image. Let's make a note first so that we don't have to rewrite the Docker commands if there are any mistakes. This time, we will copy the previous steps when creating the mongod container, but now we will add a bind mount. Here, we will specify the source folder in this directory and the target folder from mongod. To determine the target path, you need to search for it in the mongod express image on Docker Hub. Please make sure to refer to the official Docker Hub documentation for the mongod image to find accurate information on where mongod stores its target data inside the container. Let's find out where is the target folder for mongod Docker. Okay, we found it. Put it in /data/dub. Let's just copy it to the target path. So, let's add the bind mount to the mongod container creation command. After that, we can run the container and verify that the bind mount is working by checking the mongod data stored in the specified source folder on the host system. Let's create the container, then run the container. If we see the data in Docker Mongo is already stored in the source path that we have created, I happen to save it in this folder. By using a bind mount, we gain flexibility in managing the data inside the container and ensure that the data is preserved even if the container is deleted or replaced. Bind mounts have been available since the early versions of Docker, but in the latest versions, Docker volumes are recommended. Docker volumes are similar to bind mounts, but they come with additional volume management capabilities. With Docker volumes, you can create volumes, view a list of volumes, and remove volumes. To create a volume, you can use the Docker volume create command docker volume, create volume in it. We can use the following command to list the volumes docker volume else. To delete a volume, we can use the command docker volume armname volume. Alright, let's make some notes first. By utilizing Docker volumes, we can easily create, manage, and delete volumes used by Docker containers. To create a Docker volume, simply execute the command docker volume create volume name. We first check the entire volume. We will create a volume with the name Mongo volume. There is an error need to add the word volume at the time of making. If we check the volume list, we can see that Mongo volume has been created. Now we will delete the volume. After deleting it, we will check the volume list again, and Mongo volume is no longer present. The volumes that we create can be used by containers. The advantage of using volumes is that even if we delete a container, the data will remain safe within the volume. Here's an example command to run a container with a volume. Docker container create name mount type equals volume, source equals volume name, target equals path image. Alright, let's make some notes first so that we don't have to rewrite the Docker commands if we make a mistake. We will copy the previous command and modify the port to 27019. We will change the mount type to volume and set the source to the Mongo volume that we have created earlier. Let's create the Mongo volume first, and then check if it exists. Mongo, we have made the volume. Next, we will execute the script. We check in the ls container that the container has been created but not yet executed. After running the container, we can see that it is running on port 27019. Let's open MongoDB Compass and verify if the data is present. Great! The data is there. This data is now stored in the Docker volume that we have created. When creating containers in Docker, they are isolated by default, which means that if you try to communicate between containers, it won't be possible. However, Docker provides a networking feature that allows you to create networks within Docker. By using Docker networks, you can connect multiple containers together within the same network. This enables communication between containers that are part of the same network. When creating a network in Docker, we need to specify the driver we want to use. There are several drivers available, each with its own use cases and requirements. Bridge. The bridge driver is used to create a virtual network that allows containers connected to the same bridge network to communicate with each other. It is the default network driver in Docker. Containers within the bridge network can communicate with each other using their container names or IP addresses. Host. The host driver creates a network that shares the network namespace with the host system. Containers using the host network share the network stack with the host, allowing them to use the host network interfaces directly. This driver is only available on Docker Linux and cannot be used on Mac or Windows. None. The none driver creates a network that isolates containers completely. Containers using the none network cannot communicate with each other or with external networks. This driver is useful when you want to run a container in complete isolation. When creating a network, you can specify the driver using the driver option. For example, Docker network create driver bridge my network. To see the network in Docker, we can use the command docker network else. To remove network, we can use the command docker network arm network name. As a note, Docker network is a feature that allows us to create virtual networks within Docker. By using Docker network, we can connect containers to each other in the same network. This enables easier and isolated communication between containers. Beforehand, let's create a script first. First, we will create a network with the bridge driver type. Then, we will check using the docker network list command to see the list of existing networks. If we want to delete the network, we can use the docker network arm network name command to remove it. We try to delete the network that we have created. You can see the network that we created is gone. After creating a network, we can add containers to the network. Containers within the same network can communicate with each other, depending on the type of network driver. To add a container to a network and enable communication between containers, you can use the network option when creating or starting a container. If needed, we can also remove the container from the network with the command docker network disconnect network name container name. To create a container network, follow these steps. First, create a network that will connect the MongoDB and Mongo Express containers. Once the network is created, you can create the MongoDB container using the previous script. Make sure the container is connected to the same network. Next, create the Mongo Express container. You can modify the container name as needed and ensure that it is connected to the same network. Start the MongoDB container by running the command docker start MongoDB container. Finally, start the Mongo Express container by running the command docker start Mongo Express container. By following these steps, you have successfully created two containers connected to the same network. The MongoDB container will store the data, while the Mongo Express container will provide an interface for accessing and managing the MongoDB data. Now we run according to the steps that have been made. We open Docker Desktop. It turns out that everything has been run. We try to open Mongo Express. Now we can use it to store data in MongoDB with Mongo Express. After downloading images, creating networks, volumes, and containers, sometimes we want to view the details of each of these components. For example, we may want to know the details of an image, such as the command it uses, the environment variables it uses, or the ports it exposes. Similarly, we may want to view the details of a container, such as the volumes it uses, the environment variables it has, or the port forwarding configurations. To inspect an image, container, volume, or network, you can use the following commands. Inspect image. By running the docker image inspect command followed by the image name or ID, we can obtain information about the image, such as its ID tags, size, created date, exposed ports, environment variables, and layers. Inspect container. Running the docker container inspect command followed by the container name or ID allows us to view details about the container, including its ID name, status, IP address, mounted volumes, network configuration, environment variables, exposed ports, and more. Inspect volume. Using the Docker volume inspect command followed by the volume name, or ID, we can retrieve information about the volume, such as its name, driver, mount point, and other metadata associated with the volume. Inspect network. When we run the Docker network inspect command followed by the network name or ID, we can access details about the network, including its ID name, driver, subnet, gateway connected containers, and other network-specific configurations. When using Docker, there are times when we want to clean up things that are no longer in use, such as stopped containers, unused images, or volumes that are not being used by any containers. Docker provides a convenient feature called Prune for automated cleanup. The Prune feature allows you to remove unused or unnecessary resources from your Docker environment. It helps you reclaim disk space and improve the overall performance of your Docker system. Almost all Docker commands support the Prune functionality. Here are some examples of using Prune with different Docker commands. Sure, let's save the script first. By using these commands, you can clean up unnecessary data in your Docker environment and ensure more efficient resource usage. Make sure to proceed with these actions carefully and ensure that you don't delete any data that is still needed. If you want to remove unnecessary data in containers, simply type the command docker container prune. For removing unused images, you can use docker image prune. And to remove unused volumes, use docker volume prune. To remove unused networks, use docker network prune. In the future, we will study Dockerfile and Docker Compose.